Hi guys, now we are going to discuss the topic number system. This chapter is very important and all the concepts on the numbers we will learn in this chapter. Right? Right. Before going to in this chapter, do we use numbers in our daily life? Do we see the numbers in our real life? Yes. What kind of numbers we see? Do you see MRP is 36.50, 80.50, 80.25, right? These type of numbers can we see or not? Yes. There is a certain name for that numbers, but in our daily life, we don't use the names of that particular numbers. We will say just number, right? But 36.50, 2.80, that numbers are called the decimal numbers, right or wrong, right? So that all comes under the classifications of the numbers. So first we start with the classification of numbers, right? And it is also called as a number chart also. We will see different kinds of numbers, and then after that we will discuss each classification detailedly, right? Right. First, the classification of numbers, right? So basically, the numbers is divided into two parts: real numbers and complex numbers, right? The complex number example is a plus ip, right? The complex numbers is the combination of real number and imaginary number, right? This a is the real number and I is the imaginary number, right? It is imaginary number is denoted by I. It is denoted by I, and the value of I square is minus 1, right? So I is nothing but root of minus 1, right? Coming part to the real numbers. Real numbers is further divided into two parts, right? It divided into irrational and the rational. It divided into two numbers. It is rational numbers and irrational numbers. What is irrational numbers? What type of irrational numbers we call? Root 3, root 5, these type of numbers we call as a irrational number. Pi, e, etc. Right? Again, for the rational numbers is divided into integers, fractions, and the decimals. Right? It is further divided into integers, fractions, decimals. Fractions will be in the form of p by q. So examples 2 by 3, 1 by 3, that all called as a fractions. Decimals. Again in decimals there will be terminated decimals and repeated or recurring decimals, right? Terminated decimals like 0.25, 0.5, these type of numbers are called the terminated decimals. Repeated number 0.33333 or 0.83333, these type of numbers are called as the repeated decimals. Okay, further we will see detailedly. Okay, don't worry about that. And for the integers, again for the divided into negative integers and the whole numbers. The combination of the whole numbers and the negative integers is nothing but integers, right? Again, whole numbers is further divided into 0 and natural numbers. right? What are the natural numbers? 1, 2, 3, 4, so on, right? Okay. This is the number chart, guys, and also called as a classification of the numbers. You will have different number charts in different books. It depends on how the convenient is, right? This is the basic thing what the numbers is, right? Now we'll discuss what is what, right? Good. Now we discuss what is natural numbers, right? Right. In our school days, we used to have certain rule numbers, right? From where, from which number the rule number starts? 1, 2, 3, 4. How they call? 1 present, 2 present, 3 present, right? Right. These are the numbers where we use. In the month of the calendar, right? In the calendar, every month consists of what type of numbers? From which number it starts, right? That in the calendar also we see 1, 2, 3, 4, 5, then 30. Some months have 31 days, right? So what are these numbers? These numbers are called the counting numbers. So all counting numbers are called the natural numbers. Called the natural numbers. And denoted as n, right? If anyone ask count the number of toys, then what you say? 1, 2, 3, 4, right? That numbers are called the natural numbers, right? You will have the infinite natural numbers, right? We see some more numbers from the natural numbers, right? First one, even number. All natural numbers divided by 2. All natural numbers divided by 2 is called the even number, right? It is denoted as 2n. It is denoted as 2n, right? Example: 0, 2, 6, 8, 10, so on, right? 0 is also an even number, right? Next, odd number. All natural numbers which are not divisible by 2. All natural numbers which are not divisible by 2. In simple words, we can say other than even numbers. In simple words, we can say other than even numbers is nothing but odd number. It is denoted as 2n plus 1 or 2n minus 1, right? Example: 1, 3, 5, 7, 9, so on. These are called the odd numbers, right? Now we see the some properties on even number and odd number. We see the properties, right? If you take two numbers, say that 2 and 4, what is this? This is an even number. This is an even number, right? So if I add two even numbers, what I get result? 2 plus 4 equal to 6. So I got the result even, right? If I multiply, now, what happens? 2 fours are 8, right? What I got? Even into even, is even, right? If I take another example, 8 and this side if I take 4, right? Or you can take any even number, right? I will take 6, okay? Subtract now. Even minus even, what you get the result? Even, right? Even minus even, you get even, right? Suppose if I take 6, 2, right? If I divide these numbers, even divided by even, what the result you get? Odd, right? Even divided even, what result you get? Odd. Is the thing every time you get odd number? No. If I take the 4, 2, if I divide 4 divided by 2, what the number I get? 2, right? So I may get odd or even, right? If I take two numbers as even, this is a properties. If I take one number even and other number as odd, we will see the results, right? So what happens? Even plus odd, even plus odd. 4 plus 3, 7. What you get the result? Odd. You take any number, right? 8 plus 5, 13, right? Even plus odd equal to always odd, right? If I multiply one even and one odd, what you get the result? 12. What is the 12? Even or odd? And what I did, even multiplied with odd, I get result even, right or wrong? Even into odd is always even, right? Next, if I take 12 and 3, if I do division, even divided by odd, even divided by odd is always even, right? You can take any other example also, okay? You can take any other example. If I take 24 divided by 3, what is the result? 8, right? If I take 28 divided by 7, what I get the result? 4. So even divided by odd is always an even, right? Now we see in the combinations of even, 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 odd. Now we see the combination of odd, odd, right? If I take the two numbers, one number be 3 and one number be 7, right? If I add these two numbers, what happens? Odd plus odd. What the result you get? Even, right? Odd plus odd, always you get even. If suppose I deduct 3 from 7, what I get? The number even. You can take any numbers, ma. You can take any numbers. If you take 17 and 11, right? 17 plus 11, 28, even number. 17 minus 11, 6, even number, right? Now, if you multiply, now you multiply odd into odd, 3 into 7, what the number you get? 21. You take 5 into 3, 15. So odd into odd is always an odd number, right? See the multiple rules. Even into even is always even. Even into odd is always even. And odd into odd is always odd. Okay? Right. Now, if I take 21 and 3, these are the two odd numbers. If I make division, then what the result I get? 7. So odd is divided by odd is always odd. Suppose if I take 51 and the another odd number 17, if I divide it, what the result I get? 3. So that is odd number. So odd divided by odd is always odd. And another thing, odd divided even is never possible, right? Is never possible. Even divided by odd, yes, it's possible. You get the even number, right? But odd divided even, never possible. These are the properties, very, very useful in the simplifications, right? Clear? Right. Next, we go to the next concept, prime number. Very, very important. Prime number, right? Right, what is prime number? Any number, any natural number, right? Any natural number which is divisible, which is divisible by 1 and itself, right? 1 and itself, then it is called a prime number, right? Example, 2, 3, 5, 7, etc. Right? These are called the prime numbers. In another way, we can say that a prime number have only two factors. Prime number have only two factors. Remember, guys. Then that number can tell as a prime number. What will be the two factors? 1 and itself. That's all. See if 3, what the multiples you have? 1 into 3, right? So 1 and 3, 1 factor, and 3 is the number itself, the other factor. You have only two factors, right? If you take example for 21, what are the multiples you have? 1 into 21, 3 into 7. How many factors you are having? 1, 3, 7, 21. You are having the 4 factors, right? So then 21 is not a prime number, right? 21 is not a prime number, right? Now I will give 1 to 100. Between 1 and 100, I will give the prime numbers between 1 and 100, right? Very, very important. You might get the bit also. How many prime numbers consist between 1 and 100? You have 25 prime numbers. Guys, listen carefully. You have 25 prime numbers, right? So 1 to 200, you will have 46 prime numbers. Okay, we will see 1 to 100 prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, right? 23, 29, 31, 37, right? 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97, right? You have 25 prime numbers between 1 and 100, right? 1 to 50, you have 15 prime numbers, right? 51 to 100, you have 10 prime numbers. Combinedly, you have 1 to 100 prime 25 prime numbers between 1 and 100, right? Clear? Right. We see the some properties on the prime numbers. Right. First one. 2 is the only even prime number. If the question asked which of the following is the only even prime number, then answer should be 2. Right? And odd numbers, see, rest of the numbers are all odd numbers only. See it, observe, right? If you want to ask a bit like which is the lowest odd prime number, so lowest odd prime number is 3. Which is the lowest prime number? Lowest prime number is 2, right? Even prime number and lowest prime number, right? Don't think that 3, that is lowest odd number. If we ask lowest prime number, then the answer is 2. And even prime number, 2. Lowest prime number, 2. Lowest odd prime number, 3. Right? Understood? Right. Right. Next, the third property. The remainder of the division, the remainder of the division of the square of a prime number, square of a prime number, that is p greater than or equal to 5. So the prime number greater than or equal to 5, the square of a prime number which is greater than or equal to 5, right? Divided by 12 or 24, divided by 12 or 24 is always 1. The remainder is always 1. What is the meaning of this? Right? I will explain that. The prime number greater than 5, greater than or equal to 5, it can be 5 also. Okay, we will take random prime numbers. Okay, greater than or equal to 5, not 2 and 3, right? He told that greater than 5. So I take 5, 13, 31, right? 5, 13, 31, right? Now what is saying? This is square, 5 square, right? When this square was divided by 12 or 24, right? The remainder will be 1, it seems. What he told, the remainder will be 1. Is it right? Yes. We will see it. 12 24s, sorry, 12 2s, 24, right? Remainder is 1. 24 1s, 24. Yes, remainder is 1. Right. We will check another one. 169 by 12 or 169 by 24. Check it, ma. Are you getting remainder 1 or not? Yes. 12 14s are 168. So remainder 1. 24 7s are 168. Yes, remainder 1. You are getting the remainder 1. So what is the property? That the prime number greater than or equal to 5, if you square that number and divided by 12 or 24, the remainder should be 1. So when you get the question, like if any prime number, 199 is the prime number, right? If you get the question 199 squared by 12, then no need to check. You can write blindly, the remainder is 1. What is if the question is asked, what is the remainder of 199 square by 12? Then the remainder is 1. No need to check at all, right? In the same case, check by you. Check it, 31. What is the 31 square? 961 by 12 or 961 by 24. Check it. Are you getting remainder 1 or not? Yes. 12 8 is there? 960. Yes, you are getting remainder 1. 24 40 is there? 960. Yes, you are getting the remainder 1. Yes. Right. Clear? Good. And now we see the prime numbers between 100 and 200. Right? We see prime numbers between 100 and 200. Earlier what we have seen? The prime numbers between 1 and 100. Now we see prime numbers between 100 and 200. Right? So what he told? How many prime numbers do you have? 46. So from 100 to 200, how many prime numbers will you have? 46 minus 25. So you will have total 21 prime numbers. So 1 to 100 you will have 25 prime numbers. 100 to 200 you will have 21 prime numbers. Right? We see the prime numbers between 100 and 200. Right? 101, 103, 107, 109. Right? Next 113, 127. Okay, we'll put in an easy way. 127. Right? So next 131, 137, 139. Next 149, 151, 157, 163, 167, 173, 179, 181, 191, 193, 197, 199. Right? So 100 to 150 we have 10 prime numbers, and from 150 to 200 you have 11 prime numbers. Okay, we have 10 and this part 11. Here we have 15 and this one 10. Right? This is the overall prime numbers concept. Right? Next concept is twin primes. What is twin primes? Tell me more. What is a twin primes? A pair of prime numbers. A pair of prime numbers having a difference 2. That's all. Having a difference 2 is called the twin primes. Right? Let's see the examples. See here the difference 11 and 13. See here 5, 7, 3, 5. What is the difference of 3 and 5? 2. Then 3, 5 are called the twin primes. And 5, 7. Right? 3, 5 and 5, 7. Right? What is the difference of 5 and 7? 2. So 5 and 7 are called the twin primes. Right? Similarly 11, 13, 41, 43, 17, 19. So these are called the twin primes. 71, 73. Right? In this 101, 103, 107, 109. Right? These are called the twin primes. Right? Understood? So example, we can say example 3, 5. Right? 5, 7, 11, 13, 41, 43. So on. Right? These are called the twin primes. Next concept, co-prime. What is co-prime? See, as in the name co-prime, it is not necessarily that co-prime numbers should be the prime numbers. Okay? Don't confuse with the co-prime and prime. Two or more numbers that have no common factor other than 1. No common factor other than 1. Right? Then it is called the co-prime numbers. See, I am using here the numbers. Okay, it is not necessarily that number should be the prime numbers. See, in twin primes it should be the pair of prime numbers definitely, but in co-prime it is not necessarily be the prime numbers, right? It can be any numbers, right? So the other name of co-prime is relatively prime. It can be called as relatively prime or mutually prime. Okay, these are the other names for the co-prime numbers, right? If I take the example 13, 15, right? These two are the co-prime numbers. See, 13 is a prime number, right? 15 is not a prime number, but still we can say these two numbers are the co-prime numbers, not necessarily be the both the numbers are prime numbers, right? If I take 21, 22, right? These two numbers are not the prime numbers, right? This one odd number, this is even number, but still these two numbers are co-prime, right? Right. Now we see the properties under the co-prime, right? The first point, any two consecutive natural numbers, right? Any two consecutive natural numbers are co-prime. Any two consecutive natural numbers are co-prime. What is the consecutive natural numbers? Like 1, 2, 2, 3, 3, 4. Any consecutive natural numbers. It can be 71, 72, right? Or co-prime numbers, right? Right. Second one, if two numbers having HCF 1, okay, that numbers are said to be co-prime, right? This can be taken as another definition for the co-prime numbers, right? What they are saying, if these two numbers having HCF 1, then it is also said to be a co-prime numbers, right? For example, if I take numbers 15, 16, right? What is the HCF for 15 and 16? Is there any common multiple between the 15 and 16? No, right? So they are having the HCF only 1. That is only one common factor, 1. So 15 and 16 are said to be co-prime numbers, right? And the third property, any two prime numbers, right? Any two prime numbers are said to be co-prime, are said to be co-prime numbers, right? If I take example 31 and 37, right? These numbers are said to be co-prime, right? Any two prime numbers, you take any two prime numbers, the two prime numbers definitely will be the co-prime. When two numbers are said to be co-prime, when two numbers are said to be co-prime, a LCM of two numbers, LCM of two numbers will be the product of two numbers, product of given two numbers, right? If you want to find the LCM, not required to do the steps, right? Just product the co-prime numbers. For example, if you want to do the LCM for 4, 5, right? So these two are co-prime numbers, right? So these two are co-prime numbers. So LCM will be the product of the given numbers, right? So 4 into 5, 20. So LCM will be 20. Just if you want to find the LCM for the co-prime numbers, just product it. That's all. Right? These are the properties for the co-prime numbers. Clear? Understood? Right. Next. Next we will discuss composite number. What is composite number? What is composite number? Right? Any natural number having at least one factor, having at least one factor, other than 1 and itself, other than 1 and itself. What is the meaning of that? If the number, if any number is having factors 1 and itself, then that is a prime number. If any factor, any extra factor other than 1 and itself, then that number can be taken as composite number, right? The lowest composite number is 4, right? Lowest composite number is 4, not 1, right? And you need to note that 1 is neither prime nor composite. Why? Because 1 is the factor for each number. That is the reason the 1 is neither composite nor prime, right? 1 is neither prime nor composite number. So lowest composite number is 4, not 1. Most of the people make the mistake. Lowest composite number they will write as a 1. So 1 is neither prime nor composite. See, what are the factors for the 4? What are the multiples? 1 into 4, 2 into 2, right? So 1, 2, 4. See, you have the extra factor other than 1 and itself, right? See, if you have the factors only 1 and 4, then definitely that is a prime number. But in this case, you are having the extra factor 2. So 4 is not a prime number. So it is a composite number, right? Understood the difference between the composite number and the prime number? Right, good. Next concept is whole numbers. Now we will discuss the what is whole numbers, right? Whole numbers. When you add the 0, right? When you add 0 to the set of natural numbers, when you add 0 to the set of natural numbers, then that numbers are called whole numbers. That's all, very simple, right? So it is denoted as W. So when you add 0 to the natural numbers, right, then it is called the whole numbers, right? Next integers, right? Next integers. What is integers? Integers at initial chart, if you remember the chart, how you get the integers? Negative integers and whole numbers. What it is saying based on the chart, what we can say? Tell me, ma. We can say that the extended set of whole numbers in which negative integers also included, then that all called as integers, right? What we can say? When you include, right, when you include, instead of add, it is better to use the word include. That's the right word, I suppose, right? When you include negative integers, right? When you include negative integers to the set of whole numbers, to the set of whole numbers, right? to the set of whole numbers, then it is called the integers. Integer is denoted as z, right? So you have from the left side it is infinity, it starts from infinity, so you will have the infinite numbers, right? Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and this side infinity. This set of numbers is called the integers. See, these are called the negative integers, which is on the left hand side, and the middle you have the 0, and the right hand side you have the natural numbers, right? So these are called the positive integers also, right? These are called positive integers. So integers is nothing but a combination of negative integers, 0, positive integers, right? This side what it is called negative integers, right? These are called negative integers. So positive integers is also called as natural numbers, right or wrong? All positive integers are called the natural numbers. Why? Because natural numbers are, what are the natural numbers? 1, 2, 3, 4, so on infinity, right or wrong? How the integers represent on the number line, right? This is the number line. Always you have the middle number as a 0, right? And the left hand side you will have the, sorry, you will have the negative values. So minus 1, minus 2, and minus 3, and this will be minus 4, right? And this is 1, this is 2, this is 3, this is 4, and so on, right? This is also so on. This is a number line where you represent the integers on the number line. See guys, whenever you have the minus symbol, see, from the positive integer, which is the greatest value? 4. But when you see the negative side, the minus 1 is the greater than minus 4. These type of things you need to remember. These are very, very important, guys. Here 4 is greater than 1, but this side minus 1 is greater than minus 4. Very, very important point, right? Similarly, if 8 is greater than 5, if you minus on the both sides, then what happens? So minus 5 is greater than minus 8. So the negative value which is having the lowest, that will be the greater, right? Simple. It is, in simple words we can say, the reverse of the positive integers. The reverse of the comparison of positive integers is negative integers, right? Understood? And the another point you need to note is 0 is neither positive nor negative. Okay, neither positive, sorry, neither positive nor negative, right? So that is the reason, see, when I am telling what are the positive integers, then you should say 1, 2, 3, 4. So when I say all positive integers are natural numbers, so 0 we did not tell as 0 as a positive integer. In the same way, when I say negative integer, it starts from minus 1, minus 2, minus 3, minus 4. So 0 is neither positive nor negative, right? If I ask what are the non-negative integers, which are not negative integers, so you can say from 0, 1, 2, 3, 4. If I say non-positive integers, you can say 0, minus 1, 2, 3, right? I say non-positive, non-negative, right? So you should include 0 in both the cases, right? Understood? So what I say, non-negative integers. What is the non-negative integers? 0, minus 1, minus 2, sorry, non-negative, right? 0, 1, 2, 0, 1, 2, 3, so non-positive, right? Non-positive, you should say 0, minus 1, minus 2, minus 3, so on, right? This is the thing. Understood? Clear? Any doubts? Right. Now we will discuss some properties on integers like sign conversions. Okay, properties on sign conversion, right? The basic points which are very important in the time of simplifications, right? Right. Now if I take a plus b, then it will be a plus b. See, a b are the both positive integers, right? 1 plus 2, you get 3, right? In the same way, if I take the negative integer and the positive integer, it should be b minus a, right? If I take minus 3 plus 5, right? 5 minus 3 equal to 2. In another way, we can say as minus 5 plus 3. In both ways we can say. So 3 minus 5, you get minus 2. So you might get here positive or negative. The result might be positive or negative, right? Because if b is greater, you will get the positive value. If b is lesser, then you will get the negative value, right? Understood? Right. So if this is the thing, then minus b, you will have a minus b similarly to that above rule. And if you have both negative, then you will have minus a plus b, right? If suppose minus 4 plus minus 6, so you will have minus 10, right? Understood? Similarly, if minus a into b, you will get minus ab. This is also equivalent to a into minus b, right? Similarly, if you have both negative signs, right, the answer will be positive ab, right? Minus into minus, you will get the result plus, right? These are very important in at the time of simplifications, right? And similarly, when you have 4 minus 6 is not equal to 6 minus 4, right? See, 4 minus 6, it is minus 2. 6 minus 4, 2. So this rule is very important, guys, right? So a plus minus b is not equal to a plus minus b, right? Understood? So I will put in clear way. If I take a equal to 4, then what happened? A plus minus b is not equal to here minus a plus b, right? The value of b is right. For the condition, I will put here minus 4 plus 6, right? So you can't say that 4 minus 6 is not equal to minus 4 plus 6. That is, b minus a is not equal to a minus b, right? Understood? Clear? The properties are clear. These two properties are very important, guys, right? When you multiply minus into plus, you will get always result minus, and the result minus into minus, you will get always result plus, right? Understood? For suppose minus 5 into minus 3, you will get the result 15, not minus 15, right? If suppose if I have minus 5 into 3, you will get minus 15, or 5 into minus 3, you will get minus 15, right? Important rules at the time of simplifications, right? Understood? Clear? Right.